Hello. Today I'd like to discuss correlations. And as always, if there are things that are unclear or questions that you don't feel have been answered entirely, please feel free to contact me about that. Let's talk about what they mean conceptually first. So if we have a group of people, as you can see in the slide, who have answered questions about two different variables. In variable 1, we see the first person in the lower left-hand corner who had a very low score on variable 1. This person also, you see variable 2 along the bottom, had a low score on variable 2 because he's very close, or she is very close to the 0 and the 1 area. If we pick the person in the upper right-hand corner, then on variable 1, this person had a fairly high score on variable 1 and also on variable 2. So on variable 1, it would be something a little over a 4, and variable 2, something a little under a 5. And everyone in between has varying scores. But if you notice that there's a pattern here, that the people in this study, if they had a low score on one, they also had a low score on the other. And if they had a high score, they also had a high score on the other. And so we have what is a correlation, or more often called a regression line, that runs right through all those people. So a perfect correlation, which in social sciences you're never going to have unless you're correlating with itself, is a straight line, and everybody is on that straight line. And this would be a correlation of 1.0, which means as one score goes up, the other one also goes up. And they go up by the same amount. So let's make it a more specific example. And I know I keep going back to this because I think it's the easiest to conceptualize. At the bottom, we have height, starting at 56 inches and moving up to 80 inches. So a pretty small, short person to a very tall person. And then at the bottom, we have the lowest that's showing at 100 pounds all the way up to 250. So that the person in the upper right-hand corner weighs about 180 pounds and is about 68 inches or 5 foot 8 inches tall. And it would keep on going as we got taller people. It's a straight line, and everyone is exactly on the line just like before. This is a perfect correlation of 1.0. And we even have a formula for it. So for every 4 inches someone is taller, they're 25 pounds heavier. Now, one question that you might have is, does it matter how much heavier as long as it's consistent? And the answer is no. So you change the weights over on the left-hand side. And so even if the weight is going up at a more rapid pace per inch, it doesn't change the correlation as long as everyone is still on that line. So that means everyone is a little bit heavier per their height in this second example. This is a perfect direct correlation. Perfect because it's a 1.0, everyone's on the line. Direct because as one goes up, the other goes up. This is the opposite. It's a -1 correlation. It's called an inverse relationship. So that means as someone has a low score on one variable, they have a high score on the other. And if they have a low score on the first variable, I may have just said that. But anyway, the variables move in the opposite directions. So what do you need for a correlation? You need two variables. Variable 1 has to be continuous. Examples of this would be age and income. Continuous, meaning that the difference between one number and the next is the same as between any other two numbers. The difference between being 3 and 4 years old is the same as moving from 40 to 41 years old. Income is the same thing. If you have 10 more dollars, it doesn't matter whether you start at 100 or a million, it's still 10 more dollars. Now, technically and statistically, they're all supposed to be continuous like that. We can cheat, though, and use ordinal variables, meaning that there's a natural order to them, but the difference between 1 and 2 may not be the same as between 3 and 4, just like a Likert scale that goes from strongly disagree to strongly agree, and usually has 5 points, but it could have 7, 8, 9, whatever, as long as there's a progression there. So technically, we're not supposed to do it that way, but everybody does. So I'm giving you permission right now to use Likert scale questions. The second variable also has to be continuous or ordinal. You can cheat on the second one as well. I should note that as the number of values, say you have a Likert scale that has only 3 points, as it goes below 5, you can still use it, but the usefulness and the accuracy of your correlation becomes weaker. So when we're interpreting them, as I mentioned before, a perfect inverse correlation is -1, and a perfect direct correlation is +1. Most correlations are much closer to 0 than that. And if a correlation is 0, that means that your score on one variable is totally unrelated to the other. It gives us no information at all about the second variable. A correlation will also have a p-value attached to it. And just like most statistics, if it's 0.05 or less, that means it's significant, that we can trust that the relationship is there in the population just like it is in the sample, or something close to it. And then usually the N is listed, or the number of people that answered both question 1 and question 2. And I do want to emphasize the fact that negative correlations are just as important as positive ones. They mean the opposite, but they're valuable information. So let's look at some printouts from SPSS. And if you do a printout, a correlation table, so in this case there are 5 variables. If you look along the left side, there's an IQ score, a depression score, anxiety, social functioning, and general well-being. And if you look along the top, it's the exact same variables. So in this example, it wouldn't look like this. First of all, there wouldn't be a little man there, but there would be no pink squares, and these faded ones in the upper right would be just as dark as the one on the bottom. The reason that it's done this way, first of all, the pink, is to highlight what that means. If you notice on the left and then at the top, these are both IQ scores. So we have a perfect correlation. It just says 1. Because it's being correlated with itself, every number matches the number in the other variable. 122 people answered both questions. Their significance is irrelevant because it's perfectly correlated, and we can ignore that. Another thing we can ignore is this upper right-hand corner, where these results are exactly the same as the ones in the lower left. So for example, if we go across from the IQ score on the left, and then we get to the second column where it says depression, that's faded. Just like is if you look at the IQ score at the top and go down to the second square, and that's also correlated with depression, the numbers are exactly the same. So it's not that it's useless information, it's just duplicated information. It's redundant. And so you can ignore the upper right-hand corner too, which is why they have it as faded. Now let's look at the actual results themselves. We have a relationship, well, the relationship is checked between the IQ score and the depression score, and the man is pointing at that box. So let's look at the correlation itself, 0.121. And if you're not familiar with correlations, that won't mean much of anything, but it's pretty close to 0. And unless you have an enormous sample, it's not going to be significant. And even if you do, it may be statistically significant, but not very important because it's such a small relationship. Now, the second number is the p-value, where it says sig two-tailed, 0.194. It's not below 0.05, so it's not significant, and we don't attend to this any longer. Now I'd like to look at one that is significant. We see depression at the top, and we come down to anxiety, and the correlation is 0.282. It has these two asterisks beside it as a quick and easy way to see that it's significant. And if we look at the number below it, that's the p-value, 0.003. So it's less than 0.05, and it is significant, comfortably significant. So we found a relationship. Not surprisingly, people who are depressed are somewhat more likely to also have anxiety. And then that third number in the box, 112, that's simply 112 people who answered both questions. In the box below, we see depression again is being correlated with social functioning. And in this case, we have a negative correlation, negative 0.328. And it's even stronger correlation at 0.000. And just like in the t-tests, if it says 0.000, that means it's less than 0.001. So when we interpret this, what it means is people who are more depressed are, generally speaking, functioning not as well. If your depression score is high, your social functioning score is lower. If your depression score is low, then you tend to function better socially. Of course, this doesn't apply to every single person, but as a general trend. And that's correlations. A lot simpler than t-tests. Thanks.